Well, hi, good morning. Thank you so much for joining me in my shop here. Today is May 5th, and I've got two cats in here with me in case you're hearing funny sounds. But on my bench is a fantastic looking radio. Oddly enough, I own this one. Holy smokes. And look at this thing. This is in lovely, lovely condition. How something gets this far into the future and looking like this? Didn't work out this way for me, that's for sure. So this is a Westinghouse radio with a fairly popular chassis in it, I think. Has some kind of special front on it here. I can't say I've seen this kind of thing very often. So I think it's a pressed wood. They take wood and press it and squeeze it, like mold it into this shape. Wood powder and stuff, but I don't know how they get this fantastic pattern on it here. Yes, that's a cat. Wonderful radio. Beautiful shape. Okay, well, good question. Does it work? So I don't know anything about the function of this radio, if it works or not. Look at it. This is one of the cleanest radios I've ever had in my shop. There's just no dust on it. Wow. Interesting. So this is a model 697. Has 233 bands. There's a tube layout diagram, some information about it here. Speaker on the side, just the one side. And I see the wires here have been cut and reconnected now. This usually suggests, okay, the speaker's been changed or something. I don't know. There's a output transformer sitting right here. Maybe that's what got changed. Or maybe not. Maybe nothing. It's possible too, somebody took the chassis out and they left the speaker in, they cut the wires while they did the work. They put the chassis back in, they soldered the wires back together. That's probably more likely what has happened. There's a little clip here on the antenna. Well, I'm asking myself, should I just turn this radio on? Where's the string? Oh yeah. I think I should just turn this radio on. Ooh, these don't feel quite right. Maybe they're really poorly adjusted. And looks like you really can't adjust these while the chassis is in. That's kind of odd. Okay, well, I think we should give it a go. I had a radio in here, I still have it in here actually, this great big one behind me here, and before starting any serious work on it, I went ahead and tested the tubes. In the course of testing the tubes, I discovered one of the tubes was wrong. It was the wrong tube. And in the end, that's all I did was put the right tube in the right spot, and that's it. Boy, I came very close to doing a whole pile of unnecessary work. And the same thing could be true here. Let's just plug it in. I think before I do that, I'm going to get a cup of coffee, and then we're going to plug this guy in and see what it does. Okay, without attaching any special antenna or anything, we'll just operate this the way it is. This cord looks like something that was bought in a hardware store. This is looks very, very new. I will be plugging this into a dim bulb system, and that should, if there is a short circuit inside the radio, then the dim bulbs up here are going to reflect it or indicate that. So this is on, off, and tone. Imagine, yeah, off, tone. Oh, there is no on. There's just an off switch, but no on switch. Volume down, and we'll put this onto. So it's phono, broadcast, and then the two short wave bands. So we'll have it on broadcast to start. Maybe phono's actually a better place to start it. Phono should be silent. Okay. We're all set. Okay, power supplied here. because it's going through the dim bulbs, there'll be a drop, a significant drop in the bulbs. So I'll end up feeding it with much less than this, but potentially it's you can't see it there. 112 volts maximum. Okay, I'm going to flip this on. The dim bulbs are going to flash. Who knows what will happen next? Here we go. The front is lit up nicely. No sudden hum. You know, my guess is if it has a cord like this, somebody's gone and done all the restoration work already on this radio. That's not the radio, that's a cat. Oh, there's a pop. There's some static. A little bit of static. I'm just going to wiggle a few tubes here. That thunderous sound is my cats up above. So I don't know what the static is. All kinds of things. It can be this band switch even. Funny that touching this should make it noisier. The noise doesn't change with the volume. Where's the output tube? Here it is here. Okay, don't know what's doing that. Something's doing it. Okay, let's go to a band now. Turn this down. Broadcast band, no antenna. Not much happening there. Got some interference it's picking up. I think we put an antenna on here, it'll pick stuff up. Uh-oh, what happened? Did I just break the string? Uh-oh, really? This is as loose as can be now. So either the string just dismounted inside the radio, or can't really, I can reach in and, let's see the string here. Yeah, the string has gone totally slack. It's lost its strength. Okay, so I'm going to manually tune this. Oh, the pointer doesn't move anymore. Right. I don't know where I'm tuning it. Okay, that's enough. It's got to come out of the cabinet. No doubt about it. Okay, I'll get it out of the cabinet. And by the way, that was running with 100 volts of supply. We'll get out of the cabinet and take a look at it. Fantastic. You know, if it was working really well, I'd be a little bit disappointed. I kind of like it when they don't work well. That's a good place to start from. You never know where the problem's going to come. So first 3 knobs came off like these knobs should come off. Just pulled off real nice. Bit of grip, not too much. Can't get this guy off. I get the impression like it's so solid. It feels like it's glued on. Somebody have done that? No! Oh my gosh, that's a huge amount of strain I just put on it. Oh my gosh. Turn it to limit. It doesn't feel like it's... Oh! Came off. I got it off. The cats are coming down here to find out what was rolling around on the ground. So, well, that's interesting. That's the gripping piece. Whoops, I guess I banged this. That's the gripping piece that goes in here. It's like just a bent piece of metal, and it just pushes up on this flat area, and it's enough to lock the knob in sufficiently. This really gripped it. Look, it's all. This looks like somebody cut it and shaped it. There's no bend in it. So, you know, in that case, because there's no springiness, these things look pretty flat too. Maybe did it to all of them. And you shove it on there. It's pretty tight. Okay, so we have these, which are most often missing. Look at the condition of this cabinet. It's fantastic. Okay. Now, how is this held in? Almost certainly a couple of big bolts coming up from the bottom. I see there's a bottom plate on it too. Let's take a look. Two big bolts holding this together. Okay. You'd imagine it to be more than that, but whoa, this radio's. It's just me. I don't know if you can see what I'm up to here. Kind of blindly going at the screw. Something funny about the screw here. See the feet, the two back feet are missing, and the front feet somebody's put little pads on. This is an unusual cutout shape here. I wonder what that would be for. Oh, it's to give it the look of feet in the front. That's what it is. Okay, I should have these screws loose enough to undo them now. So I don't normally make people watch this kind of episode here. That's got to be loose enough. Yeah, because I don't edit my videos, and sometimes I leave them running for something like this, you get to watch these boring parts. Okay, take that off there. Now we do have the problem of how do we pull this out? This is, he may have shortened these wires up. They look a little short to me. A lot of these radios, especially European ones, are made so you can swing the whole cabinet out and leave the speaker inside. And leave the connection. I don't know if this is really long enough to do that. Let's see what we get here. Oh, it's all coming out. It's all coming out. Okay, no problem. I was fooled by this nut. Oh, it's got interesting thing in front of it here. What is going on with that? So I don't think there's any question. It's a sound reflector of some sort. You can see the shape of it. It looks like a pyramid going inside here, so it will reflect sound. And maybe this is a technique they employed, because the speaker's on the side of the radio. The trebly sound would be projected just out to the side, and so you would not hear much of the treble out in front, I think. And maybe this is their way to try to deflect some of the higher frequencies outwards. I don't know. I have something else just like this somewhere, but I don't know where it is right now. But it's something quite similar. Yeah, here's the string. Okay, so the string appears to have just dismounted. I think that's all that's happened. Yeah, let's look this radio over now. We got it out this far. Quick look at it. Very clean looking radio. And some lubrication there. Yeah, I don't think that qualifies as very good lubrication anymore. There's adjustments down in here for doing the alignment. Some over here. Looks like something there. And here. It's interesting, this is a 3-section capacitor with one section not there. So there's probably another model of radio, a step up from this one, that had the complete capacitor in it. They have another tube, probably. But this is a pretty good radio here, because you just count the number of tubes. You can go, okay, rectifier tube, don't count it. The audio tubes, we've got the output tube, and we've got the detector tube here. There's another one back here, 6JS. Don't know what that is offhand. So that's a curious one. This is the IF amplifier here, and this is the front end RF tube. So as soon as a radio has a front end RF tube, you're one step ahead, one big step ahead of a bunch of other radios. So, and typically these larger radios have that. I just don't know what this tube is. Interesting. Well, you know what? There's a schematic inside there. We can quickly take a look. So 6SA, first tube. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this shows the first tube is the mixer. Then it shows the IF tube. Then it's got the detector. Then there's the 6J5 here. It's an audio preamp for that. This tube doesn't exist in many radios. This audio preamp. And maybe they feed the phono. I bet you they do. I bet you they feed the phono into here and leave this alone. Probably what's going on. Okay, well, we don't have to study the schematic in there necessarily. But, okay. Next step will be to take off the bottom plate. I won't make you watch me do that. And see what's inside this thing, because somebody's done some work on it. Well, the bottom plate was held on with some screws of the likes I've never seen. So I just put a 1/4-inch socket on it. That's okay. But look at the I don't know what you call this inside part of the screw here. It's basically an oddly shaped rectangle-y thing. Very odd. They're all like that. Never seen that before. And probably what the guy had in his junk box, I think. I don't know. Plate off. Usually the best way to pick up these radios is right by the transformer, because that's where all the weight is to begin with. Quite a bit of like loose dirt in here. Okay. What are you going to reveal for us now? Can I stand this guy? So I'm going to stand. I'd like to stand it up with the transformer low, not up high because it's just not stable, but the speaker is here. I don't think, it wouldn't be stable anyway, even if I stood it on the speaker, which is not a good idea. Flip it right upside down. If you're sitting on this, sitting on these, it's not so good either, sitting on this. Okay, we're going to tip it up with the transformer high. I'm going to hang on to it because I think it's very unstable this way. I think it's ready to fall right over. Oh my gosh, look at this. What is going on here? You can't look at it there. Look up here. What has happened here in where this transformer is? It has poured its goop out. And contrary to what I expected, it's got all the original capacitors. I thought I'd flip this over and I'd see a wonderful piece of work. This looks cooked too. What is this? What is this? This is probably maybe. You can't see it again. I got my camera too close. This down here is probably a choke in the power supply. It looks cooked. Wow, I took an unnecessary risk turning this on because I just expected it to be fixed up. It is not. In fact, I don't see any evidence of work. Here's the power cord coming in. So take a look at this transformer here. So this is one screw holding the transformer on, and here's another one. There's actually 4 corner screw spots that are empty. This is not the original transformer, and he's barely fitted in here. Look, those are my cats having a big rustle there. So, here, never mind that. Look at this. So those guys don't know it, but tomorrow they're going to the vet, and when they come back, some of their parts won't work anymore. They don't know it though. So enjoy your manhood today, cats, because they're both boys. Today they're boys. Tomorrow, not so much. Yeah, this goes on much of the day. Okay, I've seen enough here to stop and think a bit about what to do. I think it's going to be kind of obvious what's going to have to be done. Let's look at that string again, just see if it just fell off or did it break. I don't see any broken spots, so I think it dismounted. That's not a very good sign either. So it looks like it's the original string too. Well, yeah, I don't think I'm going to fiddle with that right at the moment. Notice it's wrapped around here once, twice, 3, 4 times. That's unusual. Usually it's only 3 times in here. Maybe that's an indication this has been changed by somebody. Been replaced. Doesn't feel like a replace. Feels like an old string to me. Has what looks like original terminations on it. So I think it's the original string, and it's dismounted now. It would dismount. Why? That's a good question. The front of this. This is really. So this is a light block. This piece of cardboard here. They put in a light block, and it's to block the bulk of the light coming from this light bulb from getting in behind the glass. Because they want I was just explaining this on the last radio. They want the filament of this bulb to line up with the edge of the glass exactly, and then the photons blasting off the filament here will travel down the glass and light the whole thing up. It will look like it's lit from both sides. It'll look totally uniform. It's quite something when it works, but this light bulb is too far back for sure. It's shining just into this block of cardboard. And you see this is actually quite clever. Using cardboard here, when you put the radio in and push it up against the glass, this makes a nice seal on the glass. And maybe if you do this right, this goes all the way back and maybe the filament's revealed to the edge of the glass. But it didn't look that way when I looked at it. Right. Okay. And then have a look at the speaker. A lot of dust. The speaker appears to be in really good shape. Okay. Yeah, I'm going to stop and think about the situation a little bit. But I think it's pretty clear how to go forward with this. So I think the best move I can make with this radio is to test the tubes. Sure paid off on the last radio I did. We'll just go ahead and do them all here. And like for instance, this is the rectifier tube and 5Y3. 5Y3, I don't know. I was going to say this has to be good for the tube, for the radio to have done anything. That's not so true of a statement. 5Y3. Yeah, those are cats destroying the house behind me. HR 0600, so it's just 06 and then zeros all the way. Zero bias. Got the rectifier tube. 22 to make this read properly. English. Plate number 1. Here we go. You may have seen the fuse light come on. This is a dim bulb system built into the tube tester. If you put in a short-circuited tube, this will light up the same way my dim bulbs light up. Okay, I can see it's glowing. So we'll push the wrong, just move the wrong thing here. Line adjust. Okay, shorts. Nothing appearing. And to test this tube, we press P3 rectifier, and ooh, it's not so good. Not so good. Let's just move this a little bit. Oh heavens, look at this. What's going on here? Ooh. Wow, this I've never known this control to be like that. Was it is it 22? It's supposed to be at 22. And you know, it's an old tube tester. Who knows how accurate? Wrong button, Jim. Well, this is suggesting this is a weak tube. Now we got to do. This is a 2-part tube, so we'll do the other part. Change the 6 to a 4. 22 to 18. Same thing. So it's gone up and then it's drifting downwards a little bit. Well, I think this would qualify as a weak tube, but I don't think it would stop the radio from working. We're going to put it back in for now. And the next tube will be the output tube, 6V6. Is that the original tube? Let me look in the cabinet here. It's just in the next room. And the answer is yes, that is the correct tube. I thought it might be a 6F6 that would go in there. 6V6. 6V6. TUV 6V6. Here we are. 6.3 JR 5347. 5347. The 2 on the end. 21. For the bias, 85 to make the good bad read. So this English control operates to make the replace and good accurate if you set the meter control here to English. But if you set it on any one of these scales, 3,000, 6,000, 15,000, then you're reading the actual numbers. I like that better. So we'll put this on 3,000. So this tube, 2300, and it's time to get rid of it. So way up here on the scale, it's time to get rid of it. 3700 is right off scale. So we're going to switch to the 6000 scale. 3700 is right about here now. That would be a brand new version of this tube, supposedly, according to this tube tester. And 23 down in this area, time to get rid of it. So they say. But times have changed. So if a tube tests low enough that back in the day you'd say to the customer, you got to buy a new tube. Today, no, I don't think so. All these radios come with a major weak tube compensating control. Most people don't realize that. There's a weak tube compensating control on all these radios. It's called the volume control. So for quite a while, a weak tube, you can compensate just by up the volume. Not all tubes, but in many cases. So don't be throwing away tubes willy-nilly here. P4 2300. Beat my finger. Oh yeah, wow, it's way up there. It's way up there. She's a beauty. So the output tube and the rectifier tube are they work harder than the other tubes, and they can wear out sooner. And the cathode being the thing that's wearing out. 6SQ7. 6SQ7. What a nice way to spend your morning, testing tubes. JX 1603 with a 2. 1603 with a 2. 11 and 34. 11 and 34. Now, this control only matters if you have this on English, by the way, which I don't normally have it. So this tube is throw it away at 470, so just down around the 500 mark here. Rejoice if it gets to 750 up here. And this is a 3-part tube. This is the triode audio amplifier part of this tube. 1603. 1603. 2. Okay. So you can see the short light flashing a bit here. The flashing is okay. If it stays on, then we got a problem. P4 above my finger. Oh, rejoice. It's like 750 there. Okay, not really necessary, but let's do the other ones. JX 0503 with a 6. 0503 with a 6 out here. 11 English 0. P1 English. So now we're looking just at this thing that says diodes OK right in here. So you just got to get above this little marker line on the diode test. It's way above. Okay, and when we do the next one, we just change the 5 to a 4 and P1 again. This tube is fine. It's good. It's very good, in fact. Okay, let's see if we can get the next guy out of here. This is the 6J5. 6J5. That's not a common tube, I don't think. Not in my world. JR. These set the heaters. Incidentally, this tube tester comes with some labels up here you may not be able to see. Filament, grid, plate, screen, cathode, suppressor. Oh my gosh. I thought this was the screen all the time. Good thing I read those. Okay. So 5307. 530 whoops 07. 0 on the end. No suppressor. 23. 73. P4 for the test. In you go. So a lot of radios would not have this particular tube. They would go straight from the detector tube and its triode straight to the output tube. Not this radio though. Okay, looking for shorts. Short test always important to protect the tube tester. And I don't mean me. Okay, so 1260, 2000. So 1260 about here. Get rid of it. 2000. She's like new. Whoa! How'd that go that high? Okay, let's just double check. That's kind of crazy. So these have to be correct. JR 53070. 53070. 23. Oh, I'm on English. That's what it is. That's what it is. Okay, let's try again. 1260. Okay, 1260, about here. Went even higher. How can it be higher? 2000 is what it's supposed to be when it's new. And it's going right up to 3000. Does that indicate a problem? I have another tube tester to test this in. So we're going to do that. For now, this tube is better than expected. Better than it should be. Okay, next one here. I'll put this down on the other tube tester. 6SK7. Very, excuse me, very common tube. 6. QRSK. SK7. 6.3 JR 4765 with a 3. 4765 with a 3 on the end. 22 and 72. 22 and 72. One of the mistakes that's easy to make with a tube tester when you're reading these, especially these roll charts, is the chart can roll a little bit, and you accidentally start reading the notations for a different tube, and you get them mixed up. It's very common for me to do that, so that's fine. Usually double checking all this stuff. 4765, 47653. Good. 7653. 7653. That's my old phone number when I was a kid. That's the last 4 digits of my phone number. Hey, maybe it's a lucky day. Okay, we're on the 3000 scale. 1200 is throw it away. 1900 is happy day. Oh, I guess I can plug it in. I'm not going to get a good result. So you can imagine these tubes sit around for years and years and years, and even though they're inside an evacuated glass bulb, there's stuff going on in there. There are gases and other materials locked in the componentry inside the tube, in the metal, in the glass, in the if there's some kind of plastic materials, which I don't think there is, but there's glass-like materials in there, and they can off-gas. And that gas can be floating around inside the tube. Now it has something called a getter, which is supposed to chemically absorb that gas even as it comes out over the life of the tube. But you could just imagine, and I don't know if this is really true, the tube's been sitting around for a long time, it's gassed up. When you switch it on, that gas is in there interfering with its operation. It's just my imagination saying this. Once the tube gets hot, the outside of the tube gets hot, the getter starts activating. It starts sweeping this stuff up. Is there any significance to anything I just said? I don't know. But it's fun to think about these things. It's fun. I think it's fun to apply. You know, we got these fantastic imaginations. Us human beings, we have control over our imaginations, which is what's so different about us from many other animals. We have complete control over our imagination. So put it to work. Just think about what must be going on in these things. Imagine it all. There's a lot more going on in these tubes than we think based on the diagrams that we see on schematics. There's a whole intriguing thing going on inside here. I mean, this is a particle accelerator in my house. This is a particle accelerator operating machine. Okay, enough blabbing. And, you got to amp up the excitement somehow. You know, so I like thinking about the people who worked on this stuff so long ago, what they would say if they saw me doing this to the radio that they worked on in a factory when they were 26 years old. 1200 and 1900. So on 3000 scale, we're up just above 1900. It's like new. It's like it's testing new. Wonderful. You only have 1 tube, that's kind of questionable. Well, maybe 2 tubes. Maybe the rectifier. 1 more tube to go. Here. This would be the 6SA7. Yes, it is. 6SA7. In the same way that computers have chipsets, radios had tube sets. 6SA. So often you find the same set of tubes in a radio. So 6SA, 6SK. It's really a 6A, a 6K, a 6G. That's really what you could call these. The S stands for single-ended, which means all the pins are on one single end. There's no cap. That's where the S comes from in the tube thing. If you're a skilled radio guy, you know all this stuff. I'm boring you to death telling you this stuff. 6SA, but if you're new to this, there's a lot of stuff to learn. JR7346. JR7346. And in today's world, learning stuff is nothing anybody should be afraid of at all, because there are so many aids to learning anything at all. We can face all kinds of stuff because there's so much support to help understand whatever it is, fixing your car or whatever it is you're doing. My wife's into gardening, so she gets a lot of information about the gardening. That's the way the world is today. You don't have to go to the library. There we go. Plug it in, Jeff. Plug it in. I'm talking too much while I'm doing this, so I better double check a few things here. JR7346. 7346 with a 5. 21. 34. We're good to go. In today's world, we are constantly confronted with things that make us feel scared about the future and that. I'm talking about the American tomfoolery that's going on right now is causing virtually everybody in the world to be anxious, and we have to fight that ourselves. The press is not going to help us with that. The politicians, well, actually Canadian politicians kind of helpful on that front, but for the most part we got to figure out how to keep ourselves sane in a world that's basically gaslighting us. Every time we look at a YouTube video or something, you're being gaslit by it. Okay, focus, Jim. You're losing your entire focus here. I did this already, didn't I? Did I? I don't even know. I'm losing my mind here. P4. Oh, what are the numbers? 470 and 750. So 470. This one didn't look so good. Yeah, it's up there. She's okay. So we have one tube I want to do in another tube tester. Let's see what it says. Let's grab that tube and just repeat it here. 6J5. 6J5. Maybe I did something wrong. 6J5. JR 5307. 5307 with a 0 at the end. 2373. 2373. 5307. 5307. Okay, so this guy's got to be above 1200. So pretty much over the center line, and we're happy. That's right. This is the one that went way high. Let's fiddle with this bias a little bit and see how sensitive this tube test is to the bias. Pretty sensitive. So I see, if this scale is inaccurate and it's an old tube tester, then it may be. Sometimes I swing this control and the needle hardly moves. Other times it moves a lot, so I usually wonder about the sensitivity of this setting. So we are going to do this in another tube tester after I drink a little bit of coffee and switch some things around here. So the last tube tester is called a dynamic tube tester, and it actually tests or measures the GM or transconductance of the tube, which is related to its amplification and other things about it. This is also a transconductance tube. In fact, on here it says mutual conductance tube checker. There's quite a few different words for the transconductance of a tube. GM is it's a common term that's used. This is the tube. Yeah. Okay, 6J5. We'll find it on here. J5, here it is. Okay, 6.3, signal level 2, bias is set to 18H. The numbers are 27305, 27305, 0610, 0610. Some tube testers, you can have the tube in the socket while you're moving these controls around. Others, no, you can't do that. I think this is one you cannot do that with, but the last one you could. Only when you push the test button the voltages are applied, but I guess there's always a problem with the heater side of things. 6J5, 27305, 27305, and 0610, 0610. Okay, 28 on the meter sensitivity, and the plate selection is F. Plate voltage selection is F. Actually, I never noticed that. Plate voltage. I always thought this was selecting the plate somehow, which pin is the plate, but that's what these are doing. Hey, you learn something new every day. So this one, 840 is the reject point on the scale here, which you're going to have trouble seeing because it's just the way this works out. There you go. See what I can do about that. I think if I cut my overhead light off, you might be able to see the dial, and then if I just calm this down a little bit, we'll do it like this. Yeah, it looks a little snowy, but you can see what's going on. Okay, first we do the leakage test. In this case, there isn't a neon light, it's this pointer. We keep an eye on and look for it to rise up. Not that little pop, that doesn't mean anything. And that's a normal unshorted tube test. Now this one, 840 is the reject point, so that's 1000 right there. So 840 is just down here, and here we go. So this one doesn't report the brand new level, but if 840, it's also showing it to be a very strong tube. But I have no reason to doubt its function at this point. So it's going back in. Okay, I think that's going to be it for today. Started a little late here this morning, so tomorrow I think what we'll do is we'll maybe mess around with the radio a bit and try to figure out what's wrong with it. That might be a bit of fun. And then obviously I'm on my way to replacing the capacitors in it and those sorts of things. So thanks a lot for watching today. The weather is supposed to be bad today. That's what one forecast says. The other forecast says no, it's going to be fine today. So I don't know what's coming, but it'd be nice to get outside. Thanks a lot for watching, and I hope you have a great day. See ya.